Welcome to this instructional video on advanced data manipulation in R using data table package. Are you still working with raw data in its original form? Well, it is time to elevate your data processing game. Within the domain of data table, we leverage a powerful operator known as colon equal to seamlessly update or create columns, enhancing your efficiency of data transformations. Let us explore the intricacies of this operator and unlock the full potential of data manipulation in R. Before we start, let me move this console to the right side for better utilization of screen space. View, panes, this one we can select console on right side and let me move it down. First, let us import the libraries, data table, and in our examples we will be using a date function. For that we are importing LibriDate library. First of all, what is colon equal to? It is a shorthand operator in data table which will be useful for update or create columns by using the reference. The syntax is in the data table, I refers to condition, LHS refers to column names, and RHS refers to the values. We can also apply by operator here. If we require more than one field, those can be entered in C function like LHS1, LHS2, it means column name 1, column name 2, colon equal to, the content should be given in the form of a list. Another form of syntax is here, first we can put the colon equal to in this quotes, within brackets, we can give column name equals to the value and the second column name equals to the second value. Like this, we can use the colon operator in data table. Now let us create a sample database to practice. I am using the data.table function to create a 4-column table. Let me execute this and see the output in this particular table. Here we have 4 columns: ID name, value, date column and text column. Now let us update a new column with value multiplied by 2. In data table within square brackets, now we are not applying any condition. Now I am leaving I as blank and in J, new column name is new underscore call colon equal to the existing column value into 2. Let us execute and see the output. Here a new column has been created. It's exactly 2 multiple of this column value. In the second example, let us update an existing field by adding 5 and wherever value is greater than 20. First let us see what are all the rows more than 20 and let us execute this code. Here we are adding 5 to the existing value and overwriting the same field. In the earlier example we have created a new field, but here we are updating the existing field itself. Let's execute and see the output. Earlier these two row IDs 24 and 21 was there. Now 5 was added to these two rows. If we observe the original table, all other rows there is no change. Only these two rows have been changed. Let us see it. All other rows there is no change in that. Only this 25 and 35 IDs were changed. Now let us add more than one field at a time. For that, in the LHS side, we can give the input of column names in C function, and in the right side, the values should be given in a list form. Here, value we are multiplying again by 2. The new column, it means new underscore call. This field we are adding a 10. Let's execute and see the output. In this, value is multiplied by 2 and the new underscore call field was added with a 10 for all the rows. The same thing can be written in a different syntax. First we are giving this colon equal to in quotes and within brackets we have to give the column name and value. Second column name equals to second value. Whenever we are giving in C function, we have provided the column names in double quotes. However, here there is no need to give the column names in quotations. You can directly give value to. Here we are creating a new field to differentiate from the above example. Let me execute this and see the output. So value 2 and new call to have been created by using this second type of syntax. In the next example, let us try by creating a column name dynamically. First, I am storing the column name. Let me change it to value 2a and execute these commands. Let us see the output. Here, the value 2a has been created. To use the dynamic column names, we have to give that variable in the brackets. And after the colon equal to, we have to enter the value. Now let us try with more than one field dynamically. Here in this example, I have stored value 3 and a new call 3 into a variable called call name 2, and that variable has been entered in brackets in the left side of colon equal to. Let me execute this and see the output. Two new columns have been created dynamically. Now let us create the cumulative sum of this value field. For that we are using cum function. Let me execute this and see the output. Here in this new field, it is storing cumulative sum of this value field. The next example, let us compute the average of this value grouped by this text column. For that I am using by operator. Let me execute this and see the output. Hey, we are getting more number of columns. I think we have to remove some of them. For that also we are going to use colon equal to operator. After seeing this mean value, let us do that deletion. Let us see the output. Here the average is showing based on this particular group. The average of these two numbers is showing for both the rows. Like this, for each group, a separate average has been computed and stored against all the rows in the particular group. Now let us remove some columns. To remove any column, what we have to do is we have to insert or assign a null symbol into the particular column name. Let me remove a single column first and see the output. This new underscore call should have been removed. Now the column is not showing. Let us also try removing the multiple columns. Let me execute this and let us see the table. All those fields were removed. To remove any column, we have to store null value into the particular column. Now let us add some days into the date field. In this particular date column, we are going to add 7 days. Let's execute and see the output. In this, the date was added with 7 days. Now let us try with a string manipulation. Here we are changing the case of this text column by using toUpper function. Let me execute this and see the output. The existing field itself, all uppercase, was stored. Till now we have seen values or text is being added to the columns. We can also add logicals, it means true or false, into the columns. Let me execute this and see the output. Based on this condition, either true or false will be stored in this is large column. You can also use the statements, a case statement in these values. Let me execute this and see the output. It is showing the category. If it is more than 15, it is showing high. If it is less than 15, it is showing low. These are all the few examples I have shown with the different variations. You can practice more by changing each argument. If you practice more, you will learn more. Happy coding! Thank you for watching this video. Stay connected for more videos like this.